Hello learner, today we are going to tackle a question on matrices. It says given matrices A, which is 1, 2, 3, 1, negative 2, 4, 6, 3, 5. B, it is 5, 4, 3, 1, negative 5, 2, 6, 2, 8. Then you are told find A transpose B minus 3A plus 2B. For easy solution of this matrix question, what you want to do is find the component A transpose B, then find the component 3A, then find the component 2B. These components, three components, you want to find now the negative of A transpose B minus 3A plus 2B independently. After you have found the results of independent components, then you are going to solve, or you want to add or minus respectively. Let's start. If you are finding the first component A transpose B, it is easier to start with A transpose. And A transpose is interchanging the rows of the matrix A into the columns. That is A transpose. Meaning, if you have the first row to be 1, 2, 3, those are being the elements, meaning the first column of A transpose, it will be 1, 2, 3. Meaning these rows are turned into columns. In the second one, it will be the second row, which is 1, negative 2, 4. It becomes the second column. The third row, which is 6, 3, 5, it becomes the third column. Meaning we have done A transpose. Now to the bit of A transpose B, meaning now we are multiplying the result which we have found there, which is 1, 1, 6. 2, negative 2, 3, 3, 4, 5. Then you multiply 2, the matrix B, which is 5, 4, 3, 1, negative 5, 2, 6, 2, 8. If you do this, now this multiplication of these two matrices gives you A transpose B. In matrix multiplication, we said the sum of elements of this row, when they are multiplied by elements of this first column and added the corresponding elements of this row, you multiply to the corresponding elements of this column, then you add. You will find the first element of the first row and the first column. Now for that case, it is multiplying 1 by 5. You add 2. You can put an illustration here. It is 1 multiplied by 5. You add 2, 1 multiplied by 1. You add 2, 6 multiplied by 6. This one will give you the first column, first row element. Now for that case, this one, if you use a calculator, it will give you 42. If you try the same for the first row, the second column, the first row, these elements of the first row are multiplied to the elements of the first and the second column, then they are added. It will give you, like now it's going to be 1 multiplied by 4. You add 2. We have 1 multiplied by negative 5. You add 2, 6 multiplied by 2. This one will be the second element of the first row in the second column. This one will be 11. Now let's try the third row. It will be 1 multiplied by 3. You add 2, 1 multiplied by 2. You add 2, 6 multiplied by 8. If you use a calculator, here it will be 53. Now you continue that way to fill all the elements of this column. For that case, they will be 26 for that one, 24 for that one, 26 for that one, 49 for that one, 2 for that one, 57 for that one. You can confirm that independently. Then now we move to the bit of 3a. We move to 3a, in which this is what we call scalar multiplication. This is what we call scalar multiplication. In that, the scalar 3 is multiplying each element of matrix A. Now let's illustrate. That is 1, 2, 3. We have 1, negative 2, 4. That is matrix A. I'm just writing. Then if you multiply, it means 3 multiplies each element in this matrix. For that case, it will be 3 multiplied by 1, that is 3. 3 multiplied by 2, that is 6. 3 multiplied by 3, that is 9. We come to 3 multiplied by 1, that is 3. 3 multiplied by negative 2, that is negative 6. 3 multiplied by 4, that is 12. 3 multiplied by 6, that is 18. 3 multiplied by 3, that is 9. 3 multiplied by 5, that is 15. If you go to the third component of 2b, then now what happens there? It is the same scalar multiplication. But now 2 is multiplying each component of matrix B. That is 5, 4, 3, 1, negative 5, 2, 6, 2, 8. The same as we have done in the first bit of 3a, the similarly is what happens at 2b. Now for that case, meaning 2, it is multiplying each element of component of matrix B. It is 2 multiplied by 5, that is 10. 2 multiplied by 4, that is 8. 2 multiplied by 3, that is 6. 2 multiplied by 1, that is 2. 2 multiplied by negative 5, that is negative 10. 2 multiplied by 2, that is 4. 2 multiplied by 6, that is 12. 2 multiplied by 2, that is 4. 2 multiplied by 8, that is 16. Now we have found independent elements of A transpose B, of 3A and 2B. When you have found these elements, now we look at our question. Find 3A transpose, not 3A, it is A transpose B, which is 42, 11, 53, 26, 24, 26, 49, 2, 57. You minus 3A, that is 3, 6, 9, 3, negative 6, 12, 18, 9, 15. Then we go to add 2b, that is 10, 8, 6, 2, negative 10, 4, 12, 4, 16. This matrix, yani this solution, tests addition and subtraction of matrices. When we said each element, corresponding elements, they are added or subtracted. For this case, it will be 42, you minus 3, you add 10. That one will give you 49. It is 11 minus 6 plus 8. That one will give you 13. 53 minus 9 plus 6. That one will give you 50. We have 26 minus 3 plus 2. That will give you 25. We have 24 minus 6 plus minus 10. That will give you 20. 26 minus 12 plus 4. That will give you 18. We have 49 minus 18 plus 12 gives you 43. 2 minus 9 plus 4, it gives you negative 3. Then we have 57 minus 15 plus 16, it gives us 58. This is the result of this question. If you have any query, meet me at my inbox. Thank you. Have a lovely day.